Okay, so while we are still waiting for more students to join, let me ask a question because I get some feedback that there are some students who are still studying like CS 103 without much programming experience. I just want to get an understanding of how many of you are like still studying the first programming language. Can you raise your hand if that is the case so that I can get an idea? Yeah, because I got a feedback from one of the students that, oh, okay, so I see two students. Mm-hmm. Okay, so not a lot, but we do have some students who need more help, right? So we will have basically 3 labs. Okay, after today's lab will be on still continue with Cisco Packet Tracer, but then we will next week we will release this socket programming lab, and then we will have 3 consecutive labs where TAs will be there helping you guys. Okay, so if you have difficulty, just let TA help. Okay, and they should be able to help you. Okay. As long as you are in 103 or you finished 103, it should be fine. Okay, because basically as long as you know some programming language, that should be fine. Okay. Yeah. So do make sure that you go through the chapter that we mentioned earlier, right? So let me open that window. Yeah, because our students have very diversified background in this class, so we need to adjust it. Okay, so basically we have the networks top-down approach. This book, right? So we have a Python library. Yeah, we have a chapter 2.7, which is the Python API for socket programming. Okay. So before we go into today's lecture, which basically familiarize with you guys with socket, right? So we will use a C socket here because C socket is the background, the backbone of all the languages. For example, Python, if you take my data science course, you know that it's basically a wrapper over the C API, okay, for the socket. Okay. And so we will look at some of those concepts here using the basic one, but the API, it would be really helpful that you use Python API because it's easier to use, okay? So let me go to. So do go through this chapter. So we have UDP and TCP, and there's also some background information about, socket programming, okay? And yeah, I see student share link. Okay, so here's what you need to read. Okay, section 2.7. Right. So we will mainly focus on TCP. So the top layer. Now you should already understand application layer, right? So the next layer, what application will be using for communication, right, with the other side, is using transport layer protocols. Okay, these transport layer protocols include TCP, UDP, and there could be other protocols. Okay, TCP and UDP are the 2 most popular ones. Okay, and the UDP basically does not require you to confirm secure link. Okay, TCP does a connection established first. Okay, so there's a 3-way handshake. But for UDP, you just push your information. Okay. Yeah, we will just do the TCP socket API. Okay, so in this project. And so let me briefly go through an overview of the TCP API here. Okay, let me see. So here in our project, we will have a server set up for you guys, and it basically writes the logic here. Okay, so this logic, okay? And you are supposed to finish this client code and interact with the server, okay? The server already has some logic to interact with you, right? And you need to finish the client code to interact with the server. So what the, this code is doing is that the server, so you think about it, if you have a service, right, like a website, you need to connect, you need to know where you need to connect to, right? And we know that you usually connect to a URL, and if you are using browser, a port number is 80, okay? And here you need to specify a port number where the program on the server that answers your request sits on, okay? So we need to have a socket, and we need to have a port number. You get this socket, which is a handle that you can, we call the file descriptor, okay? And then you can, this thing can be used for sending stuff and receiving stuff, okay? And we will talk about later. So TCP, before you can check the previous chapter on UDP, okay, so subsection, okay? This TCP, you need to establish your connection first. So this tunnel is secure, okay? You need to do through a handshake and make sure the other party is listening and will respond to you, okay? So this connection channel should be established first, okay? There's a three-way handshake process there, but because we will describe it later. So just to understand, you first need to have a connection between the server and the client, okay? And once the server has, has a socket, it will just loop, right? Because, you need to continuously receive requests from the client, answer them, and then get the next request, right? Because you are always on. It's like an infinite loop, right? So let me see. We will not be communicating with the database. Okay? We will just do some simple stuff. But if you want to use database, it's orthogonal topic, right? So basically, you can when you are here, then you can get something from the database and get it back. Okay. So another thing I want to describe is that the socket programming is really the very low level API. Okay. Usually when you are using the frameworks, right? It's a higher level. Okay. They are implemented in socket, and you are using the frameworks. That's much easier to handle. Right? So usually when you work with the backend database, you are using some framework on top, like PHP, JSP or .NET, etc. Okay, so Node.js. So there are higher framework on top. Okay, you don't go that low level, okay? But they are implemented using socket program. Okay, and so basically you will accept when some client send you a request, you accept and you build this connection. Okay, this is the server side code. Okay. And then you will have a connection socket. So the reason you need to have a separate socket to communicate with the client each time, because this socket has to continuously be maintained and receiving new requests. Okay? And this connection socket can be closed after use, okay? Because the major socket that is waiting for people to, is receiving the request here. Once you receive a request, you give another dedicated socket, okay, for the communication. And what you will do is, for example, in our example here in this page, you will establish a connection with the client, and then the client will send you something, right? And then you will see that message, and then you respond accordingly and send it back, right? If you are using some frameworks, the framework will, for example, get some data and run your code, which your code may run some like a SQL language, like a JDBC, etc. Right? Connect to the database and get the data, and write the data using like some jQuery, visualization table, etc. Okay, and then put it here and send back, right? So if you have Ajax or something, then maybe it's updating part of the web page, not the whole web page, right? So the request is just to say, hey, that particular small construct in the web page need to be refreshed. Okay, let me see. Yeah, so it's not just a ping. You need to write socket programming API. Okay, so basically these are the APIs we will go through, especially because some students have no background about programming, so we will go a little bit more detail. We will look at the code shortly. This is a high-level diagram. Okay, once you understand the diagram, then we'll zoom in each line by line code. Okay, to go through this Python API, and then we will come back to this API. The complete code is actually here. We will see. It's not difficult. Basically, you just need to know these API, what's input, what they are functioning. And what we'll do in the project, really using those APIs and put what we are mentioning in the steps into the content of the socket, right? To like what you should send to content and how to process this content and how to send it back, right? So these are what you want to do. Okay, so API is just for you to use, but you need to be familiar with it. Okay, right. So ping is usually just a command, right? So in the console or so you don't need to program. It's already a program, right? Just like a trace route you see before. But here, this is actually a program. Okay, and but this is server code we will provide for you, right? What you need to do is, you know that how server will respond to you. What you need to do is you will create a client socket and then send the content to the server to process and then take it back, okay? Right, and then finally close, right? So let me see. So here the example, let me see whether we have the server side code. I don't see a server side code. Let's just look at the client side code, right? So firstly, one important thing is that we will use a client server mode, which means client can be anywhere. But all of you need to know which machine is the server, which means you need to have an IP address for the server. Right? So here you can have a server name, right? So which is host name, okay? Right. Maybe we have a mapping from host name to the IP address locally, right? In your usually it's in, if it's Linux, it's etc host, etc. Okay, and there's a local, when you visit, you can just use host name, right? Sometimes, okay, that's because there's a mapping that is recorded by the operating system. Okay, otherwise you need to get the IP address. This basically is like a domain name service, but it's host name, okay, server name. Okay. You can also put a domain name, like google.com, okay, and you can also put IP address, right? So then you can have the port number, right? So port number means maybe there are multiple server run program run for different purpose, right? You need to tell, hey, which program I want to talk to. Okay, so this is this port number that this answering server program is run. Okay, so after that, right? So you need to connect. Okay, once you, let's say this is you. Okay, you connect to this server. Right? Of course, you first need to get the client. Okay, so this is TCP. Okay, you can also create a UDP socket. Okay, and then what you do is you create a sentence, right? This is getting raw input in Python. Simply getting from the getting from the screen. Okay, and the console will show this line, and then you input something. Something will get into the sentence. Okay, this is a string, and then you can send it out. Okay, and then after sending it out, right? So the server will do some processing and send it back. Okay, so all you need to do is just receive. Okay, and there's a receiving buffer. Okay, so how long you want to receive? Because there's a so-called buffer overflow attack, right? So if you don't limit the number of bytes or characters you receive, right, you can receive 10 gigabytes of content, right? So maybe it will go out of your program space, like a program stack, right? And write some malicious code to somewhere else that you didn't expect, right? So like the code, in the memory, you have the data and program space. You also have the instruction space, right? Like the code space. You even have the kernel space in the low end, okay? Right. And if the code flush to this code space, and maybe malicious code can be run, okay? And so this is like a cut there, okay? Beyond that, I don't receive, okay? Drop them. And so then you print what you receive, this modified sentence. Right? The server will do something like make all the letters uppercase, etc. Okay, and finally close it, because this socket occupies some results. Okay, for example, it needs to maintain some internal buffer for you when you receive or send. Okay, if you say close, like this buffer size will be recollected. Okay? There's a lot of other connection actually. Okay, there's some resources that need to be released. Otherwise, this is called like a memory leak, right? So, this socket leak, right? Because you think about it, for client, it's actually okay, because you can create a new socket and it will automatically give you another port number, right? You need to know the server port number is this number, okay? But your client's port number will be randomly assigned from available ones, right? When you call this socket, okay? Maybe this time 666, okay? Usually it's a very large number, maybe 666. Okay. Next time, if you don't close, you cannot use this port number because it's already occupied. Okay, and then you have to use maybe 7777. Right. If you do not close, then all the port number will be okay. So that's basically the high level logic. Right. And so that the Python packages are called Socket. It's very easy to use, basically. Okay. But again, so what I just described, if you look at this chapter, it has step-by-step description for you. Okay. Do go through these steps. Okay. And there's also a server-side program, right? So, and there's a, although I described line by line, but if you read it again, you can get a deeper understanding. So make sure you read this part. Okay, so section, what did I do? Section 2.7. Right. So let me also go through the server side code so that you understand a little bit better. Because C code and Python code, basically the function name is the same. Okay, let me go to where's the menu, catalog. Okay. So previously we are talking about the client side code. Okay, the server side code are here. So the server side code is something looking like this. Again, you need to import the packet, and this is your server side port number. You have to give this port number. Okay, it cannot be randomly assigned by the client, like the client, because the client need to know the port number, right? So this should be a famous port number, right? So giving an example, let's say if we go to uab.edu, right? Maybe we should not do, but this is also fine. Okay, you can say I want to use port number 80. Okay. Oh, I think maybe this page is not using 80. By default, the main page is using 80. Okay, so I think it should be here. Okay, it should be right after domain 80. Okay, let's see. Maybe HTTPS is not using 80. Let me see. HTTPS port number. HTTP, I think it's using 80. Okay. Yeah, HTTPS is using this port number. Maybe if you use this port number, you can visit. Okay, right? You can visit this web page. Okay. So actually, by default, each like this is because we are using S protocol. The default port number is 443. But if you use a wrong port number, right, you cannot visit because this server that sends you the page is actually run on that port. Okay, if you use the like 80 or other port, it will not recognize. Okay, because for famous applications, their port numbers are fixed. Like HTTPS is 443, right? HTTP is 80. Okay, and FTP is 21. Okay, so we can have the port number of apps like 80, 443, 21, etc. We should be able to find that then. Okay. So these are for the well-known applications. They are using very small port numbers. Okay, so so these port numbers are already occupied. Your client should not use these numbers. Okay. For example, if we look at 443, right, this is for HTTPS. Okay, and if you look at FTP is using these port numbers. It's just FTPS. Okay, and I think FTP is using 21 or something. So let me see, 21 file transfer. So these small ones are already occupied. Okay, so this is FTP protocol. So these things, why we need to specify these port numbers as fixed? Because when I connect to UAB website, I don't want to put a port number, and then the browser will assume the port number is the default port number. Otherwise, I will go to another application, right? But when you run some other servers, right, you need to specify the port number. Let me give you an example. Okay. Let me see how to do that. So basically, when you do, for example, I'm not sure whether you are familiar with the Jupyter Notebook, right? When you type Jupyter Notebook, it will have some port number assigned. Okay, and you have to use that port number to visit that Jupyter Notebook server. Okay. Let me see whether we can make some examples. What did I do? I think we don't have a desktop here. Let me move one here. Okay. For example, I cannot show the file. So anyway, so each application has a port number, okay, and you are connecting to the right port number, okay, and so basically this should be none, right? Everyone should know, hey, now I should be connecting this port number. Like your client should know the server's port number. So the server usually the port number is fixed because the client can just randomly select one port number that is not used, okay? Because when you send a request to the server, you need to attach your port number. So the server can reply to you and it will know which port number it should reply to. So for the client, it's fine, okay? And the AF basically is saying, you know, so we will always use this, okay, IPv4, okay? And the sock stream is saying we are using TCP. There's another for UDP we'll see later, okay? So here, both server side and client side are using, you know, TCP, okay? This is a TCP socket you get, but for server, you don't get a socket and just send the stuff, okay? That's not okay because server is serving the client's request, right? So what you need to do is you bind, okay, because by this time you don't have a port number, okay? You just create a TCP socket, okay? And then you need to bind to this server port, okay? And after binding to the server port, so you need to start listening on the port, right? Because some people may, you know, send a request to you, right? You need to listen. Okay, this is how many requests you can receive. For example, this is the maximum request you receive. Usually one may be too small. You can use 1,000. Okay, so when it's like the buffer in the router, right? So for example, if you have one request, right, already you are processing. Let's say you get a request and you're processing the while loop to receive that request and make every letter application and send. While you're still doing this, there are two more requests comes, right? If you only allow buffer one, the second request has to be thrown away. Okay, basically that is, okay? But you can queue them up if you have more requests. So this is like the queue in the router, okay? But this is the application, you know, the transport level queue. Okay? And, you know, this is not the router. Router is the hardware, right? So then once it's listening, then we will print on the screen that the server is ready to receive, okay? And then you can run this, right? So keep in mind, this socket has to be always on because this is the connection, right? So you maintain so that you can keep receiving requests from others, right? But then you can accept a three-way handshake, right? Some people send some stuff to you, okay? And by doing this, it will return another socket for you, right? And it's the address for you to respond your content to the other party, okay? Right. So what you can do is but actually you can directly send it using this send because this socket already contains, because when you accept it already contains the client IP address and the port number. We will see the header in the TCP layer because they have this content. Source IP address, source port number, destination address, and SIM port number. So you don't have to give it again. It's like a local variable inside this object. Okay, so you can send the stuff back again, right? So you can receive the content into a sentence, right? It's a string, and it makes a string uppercase, and then send it back. Okay, these are the string functions, okay, in Python, right? And then you close, because you know when you create, you need to close, right? But the other socket is always on, keep receiving. Okay. If you look at applications these days, this segment code right now is for simplicity. We don't want to incur multi-threading stuff, right? Usually it will be like something else, okay? Like if you are using some PHP or something tool, right? So there's some backend Web 2.0 service running, okay? It will say, hey, create a thread, okay, and run these things inside that thread, okay? And then after running, like throw back the thread into the thread pool, okay? Something like that, okay? Because you don't want to create a thread again. Creation also has time. Yeah. No, I see a question. So are we copying this code? No, this is the illustrative API. Our project would be more complicated, but here you can get an understanding. You can play with it basically, right? Just copy this code into Python. But in the lab, we will have more steps, okay? But we are basically in this level, right? So in this level. So we will ask you to interact with the server by changing some behavior, right? Like in this example here, we are just turn all the letters uppercase, okay? But in the lab assignment, we will ask you to do more stuff. But the APIs are still this, okay? So as long as you understand how to do that, it's just like you use it multiple times to do some logic, right? So that will be able to handle these APIs. Okay? And in a real web server, you will create a thread and wrap this as a function to be run by the thread, and then throw this into the thread pool. Okay, a thread pool usually has maybe 100 thread, and if you have more than those threads, you will create more, right, to serve some additional requests. Let's say there's a 200 like peak hour, right? There are 200 coming. Then you need to create 100 more threads. Okay, and maybe gradually when it's not peak, you can delete some threads. Okay, keep it a smaller size. Okay? The reason we need to have a thread pool and take a thread and put back to a pool because creating thread itself takes time. Okay, right? And so what is thread? Right, so thread is multi-threading computing. Right, so one thread is run on one CPU core. Okay, these days, for example, my Mac has maybe 8 CPU cores, right? And that means as long as I get the request and I send the processing code, this is really fast, but some could be very time consuming, right? To a thread, then I can immediately return and get the next request. Okay? That thread will be running on a CPU core, okay? And if you have 8 cores, you can process at least 7 requests simultaneously. That's much faster. This is what actually the web server is doing. But here we are single threaded, okay? We'll finish one and then look at the other. Right. But if you know multi-threading, you can easily work on that. Okay. And unfortunately, the Python code are, the multi-threading is fake, right? So basically, all the multi-thread code is singles, like running on the single thread, right? But even so, you will still get faster speed. For example, if you think about it, when we run this, maybe this is a database lookup, which will take some time, maybe 1 second to come back, right? By that time, if it's on a thread, get stuck, but you can come back and get the next request, right? And sometimes it's like a crawling some website. This crawling latency will be high. And then you can keep even one CPU busy, right? Otherwise, the CPU will be running something and then wait for a long time for the web page and then crawl the next one, right? Now what you can do is you can crawl web page, but while it's waiting, you run the next crawl, right? But you cannot run something like simultaneously. Okay, this is Python's limitation. Okay, unfortunately. And if you run in C or some multi-threading library, that will be avoided. Okay. Yeah, but here we are not touching the multi-threading because that's too difficult. Okay, and unnecessary for this code. It's an orthogonal topic. But in the real life, if you look at web server, it's in parallel. Okay. You cannot just serve one person and then the other one by one. It's too slow. It's concurrency, right? 100 users are querying or logging. Okay, right? So you need to handle all of them. Okay, so that's basically a walkthrough of this stuff, right? So you can create a one socket on server, right? And then you can bind the port number, and then you can listen on this start to receive packet, right? After listen, you can call accept, and if someone really sends some stuff to you, and there's a buffer, right? So when you're processing this, maybe other people come, you can queue at least one more, okay? And when receive, then you have a buffer size to avoid the buffer overflow attack, right? And you receive this, and then you can do some processing and send the response back, okay? Here we are just do some simple processing, right? Actually, in real life, for example, the web page, right? You send a HTTP request, say, hi, I want a UAB website page, right? And then it will load that web page file, writing into the string and send it back to you. Okay, now your browser will show, right? Something like that. Right, so again, that logic is by HTTP, which is on top of the TCP, okay? Right. Okay, so that's a brief walkthrough of this. Again, I would recommend you to read this chapter, okay? Because there's each line is accompanied with a very detailed description. So even if you are not familiar with programming, then after reading this, you should be able to handle the line, okay? Okay, let's go back to where we were last time, okay? So the goal is familiarize with the socket programming API, right? What are these functions? What's the typical workflow to write a socket program, okay? And why we are just presenting, previously we are presenting Python API, right? The socket package, okay? But here in this slide, we'll present C socket, okay? Because C socket are the standard, okay? And if you look at, so look at all other APIs, okay? They are all based on C API. Okay? They are a wrapper of the C API, especially for Python. Python, a lot of stuff are just the C wrappers, okay? If you take my data science course, you should already know that, And so, in this project, we will have a server setting for you. Basically, you will have the server code. Let's say some .py that you can run, and the server will be listening. Okay, and then you can use whatever language you want, and because they are just the same, they are down there is calling the C socket. They are wrapper. And previously in the lab room, we do require students to have two different machines, right? Then you can communicate with each other, right? So now it's kind of tricky because you only have maybe one laptop, right? So then we cannot show because it's networking, right? At least have two machines, right? So I would strongly recommend you to find a peer to working on this project together, right? So you can, for example, you can how to say. Then you can communicate, like see it's working, right? So you can get each other's IP address, right? And then send stuff there and get back, okay? And see whether both sides can receive, because we are doing remote, right? Maybe like you have teammates, right? Because we allow two people as a team, okay? That will, like you are at home, but the other student as his or her phone, right? And then you can send each other by sharing the IP address, okay? And negotiate a port number. If you want to use a virtual machine, that's also fine, right? So make sure the network interface is properly configured to be different in some sense. Right? You can virtualize some IP address, okay? And so to get the IP address, right? So you can use. I'm not sure. So because I don't have Windows, right? So if you are using Mac or Linux like me, you use Ifconfigure. And you can look at the IP address. This is the internal value. Okay, this is internal. So you can have a public IP address somewhere. Let me see. Somehow, let me see why I cannot find my IP. But if you are in the same machine, usually, this IP address starting from here, okay, is in the same subnet. Okay, 192 and 168, dot something. And if you have different machines, it's usually the difference is in the last two, often the last one. Okay, maybe 104 and 207. Fine. If you are in the same, like in your home network, and you have one desktop, one laptop, you can try it out. Okay, and so it will work. Okay? Otherwise, you need to get the other side is public IP address. Okay, so for that you need to find it. Somehow I cannot find it here, but I think there's a way to find it. Okay, so, yeah, I'm not sure. So I think maybe you can Google a little bit, see how you at home you can get your public IP address. Okay, then you can visit the other side, because this is like inside the net, right? So this is a little bit tricky actually. Okay, and I think because under the net it's a little bit difficult. So that's really, if you have at your home you have two IP addresses. Just use this. Okay, if you see this IP address, which is 104, but another is 105, then you can communicate with each other using this IP address. Right? You have a 104 at the server, right? You run a server code pi, and then I think there's a way to work out. Especially if you have two people in the same Wi-Fi, then it will work. Okay, and so this is called Ifconfigure. But if you are using Windows, you use Ipconfigure. Okay, and you can look at IP address. Okay, so Windows is Ipconfigure. I put in the chat. Okay. So because it's under net, so it's a little bit difficult, right? Unless you are using public IP address. Right? If you are under net, it's better you simulate. You have two IP address locally in your net. Okay, then you use two devices. Okay, maybe one is laptop, one is desktop, or two laptops. Okay. The same Wi-Fi, you need still a port. Okay, you still need a port. So yeah, I see a student ask question. So the same, because port is just saying, hey, you have laptop 1, you have laptop 2, okay? And port is which program you are communicating with, okay? Right, so these two can communicate, this can also communicate with them, this can communicate with this, right? And this can communicate with this. So you need to tell others which which program in which machine are you talking to? Which program is by port number, okay? The IP address is the internal IP address because maybe in your home network, you only have one outlet, right? This is the only IP address you purchased from the ISP, okay? So again, internally, between two laptops or one desktop, one laptop, you still need something like this, right? But the IP address will be something like 192.168.1. Maybe 50, okay? Another could be like a like 60, okay? Then you can make one client, one server, right? For the server, you need to fix the IP port number, maybe to 12,000. Okay? And then here you can get random because it's a client. Okay? Then you communicate with it, the server runs server.py, here runs client.py, and you can see the flow. Yeah, if you are not able to having two machines, just use the local IP address. Okay? Usually, you can use this IP address. It will be your own, search all the IP address. Just use this IP address. This IP address is the local machine's IP address. Okay, right. So even you are not connected to the network, you have this IP address configured. Okay? That means my server, my client is in the same machine, which is my local machine. Okay, so that's the only way if you want to do that. But this is less desirable because we are studying networking, right? So it doesn't tell too much if you only have one machine. Okay, but it will work out because it's server and client are on the same machine. Right? This is oftentimes when we do a local GBA notebook, we are doing this. Okay, and let me see. Yeah, so this is the old names of the socket we've seen before, right? And basically, it implements a TCP IP interface, okay? The TCP interface, UDP interface, okay? And so our project one will be a fundamental problem, right? So the rendezvous, which means we have a server with a public IP and a public port number, which means, hey, you need to communicate with that machine's that program, okay? Right, because you can run a FTP protocol, right? So a server program, and you can also run a J2E program, right? So they go to different points, okay? And again, if you have multiple programs running, right, you need to have different port number. You can hard code it to be different, okay? Maybe you have one Jupyter Notebook server already, but you want to run independently. You have to use another, okay? Otherwise, they will mix their message together. So this is basically say, hey, when I send message, which program should send to? Okay. No two application programs logically should use the same program, right? But you can force it to use that, but if that happens, basically you're getting two applications data, right? And the program is usually written just to answer one application's message, right? The other maybe not even able to interpret it, right? Maybe will crash. Okay, so that's not the value. Okay. And so here the running problem is that we want to, let's say, many parties want to provide a service, right? So, and like we want to let you log in using Blazor ID, right? There's a login server, right? So also wanting you to use the review website, and then you can log into Canvas, which is actually a Web 2.0 web page, right? After you log in using database, it will show you, and then you do quiz, it will record your answer, etc. Right? So the backend, okay? So in that case, there's probably multiple services, right? UAB wants to run, okay, to provide. And also multiple parties want to use the service, like our students here, right? So you want to do quiz, right? And you want to, for example, use Zoom, right? So we can teach, right? Of course, Zoom, like I think they have a dedicated server. We're all connected to that server, okay? And so how do you get them together, right? So that's the question, okay? So the solution is that you can use a client server architecture, right? So client will initiate the communication, okay? Like if you want to get something, you send the server something. But when you initiate, you need to know which machine, which is the IP address, right? And which program running on the machine I should send it to, okay? So that's program is important, okay? And the server is responding, okay? Right. So when I get requests, I should respond. Run some program, answer your question, okay? Or compose a website in the response to show on the browser. Okay? So at least the one side has to wait for the other, right? So one way is that you can have a client on all the time, but this is less desirable, right? You just think about it if you are using email, right? So you want the email server to always be on, and whenever you send or you want to receive your emails, just connect again, right? So you don't want to open your client all the time, right? So that if someone like wants to send you an email, they can send through, right? This is not desirable, okay? So that will be a central service server, right? So then email correspondence will be saved there. When you want to receive or send, you just do, and then you can close the laptop, right? So actually the responder will be always on, okay? So we will choose the server side to be always waiting for us, okay? So server will sit and wait, okay? Of course, there's a different architecture these days, okay? Peer-to-peer, right? It's totally different. It's kind of like we don't need a central server, okay? So oftentimes we want to have some server to boost the service, okay? But we will see that later. For example, for Zoom, right? You do need actually some server that are in Birmingham. So when we connect, right? So then our bandwidth is fast. If all the servers are in, like, say, California, then there's long latency, okay? And so let me see. So the client will locate the service, right? So when you locate the server, which means the server should have a public domain name or IP address, and also the port number, okay? And the client will initiate the contact, right? So the server accepts because the client is sending the request, okay? And oftentimes we are using the DNS, right? Domain name, okay? Like google.com, uab.edu, etc. Okay? So the client will use it, right? The server side actually on that server of the domain, right? The IP address running the program, okay? It's always on. So the key difference again, summary, okay? Client is on demand, okay? Server should always be on. Client is unprivileged and the server connection is privileged, right? It need to, it need to always respond to you, okay? If there's something other thing on the server that people are running, it should not stop your response, okay? Otherwise, it's like the service is down, right? The server is down, okay? Users are not happy, okay? And the client is really simple, right? And the server is usually a complex program, okay? Socket programming API, socket to API is just a communication API, right? And you also need some more complex stuff, right? You want to connect to the database, and maybe you want to show the website, right? So you have those kind of frameworks to help you. There's some semantics that you also have an interpreter to translate your code, whether it's PHP, JSP, or .js, right, into a response web page. Right? There's something running, okay? And the client is usually sequential, right? So we just wait the answer and then do it. But again, this means the client is sequential when we post a request. But maybe this time you are also doing something else, okay? Right? You are watching movies, and that's parallel, okay? For this particular connection, this particular service, you run some sequential code. Server should be massively concurrent because you never know, right? So for example, maybe 100 students of staff are connecting to the login server of UAB, right? Laser ID verification, okay? We cannot afford one at a time, okay? And that server will probably have maybe 64 CPU cores, right? Well, that also makes no sense just to use one CPU core, let another sit idle, okay? And the client is not performance sensitive, right? This is because for you yourself, right? So you are not doing much computation, okay? You are just saying, hey, help me do this, okay? And then you are waiting. Mainly the time is latency, okay, right? So the server is high performance, okay? Because it needs to at least go to the database, and then maybe you do a table drawing, etc., right? So it's doing the workhorse, right? So it's doing the actual job. And then show the result and then send the result to you, okay? So it should be high performance and scalable, right? And even if, maybe it's not just one server, it could be a data center of servers, right? So you just think about Google keyword search, right? If it's just a one machine, then it will be crazy, right? So there should be a cluster of machines, right? So serving, like share the workload, okay? So basically, maybe each time you do the keyword search, it's assigned to different IP addresses. So it's possible, okay? The entry is the same, but then it will give to another different machine to process. Okay. All right, any questions so far? again, so the similarities of them are, it's sharing the same common protocols. That's why you can communicate, right? For example, if you are using browser is using HTTP or HTTPS, right? And the HTTP server should also be one thing, right? So these days, I think people can just run a Python. I think there's HTTP server, right? Write one command, the server will be on, and then you can just put static web page. But if you want a Web 2.0, which you can interpret and then compose a new website and send web page and send back, right? And sometimes often resort to the database, etc., right? So then you need more complicated code, right? So and maybe JavaScript, okay, Node.js, right? And the browser side, browser side can also understand those. So basically, application layers they should speak the same language. Okay, if TP client is TP server, okay, and web server and the web browser. Okay, and so they should speak each other. Skype with Skype. Okay, right. And the transport layer usually the TCP UDP. Okay, you are using the same IP layer. Okay, so they are shared. Okay, and so both are relying on the API for network side. Right? So they are all using Socket API. Okay, below there you don't care because it's Socket API will handle that. Okay, like TCP will handle the the congestion control, etc. And so here, what does the socket mean, right? What we call it socket, right? So we know that socket is something like you can put in your plug and get to the electricity, right? Get the power to power your maybe device, right? So it's kind of similar, but now you are just sending not electric signals, right? You send the data, okay, and to the other side, right? So it's like a plug-in. It's very simple, right? If you think about the it's really a modularization design. Okay, so this is like for electric device, right? You have this socket to get power, and for your motherboard, right? So you can get your different, you add a memory bar, or you add a disk, etc. You have those slots. You can add a socket. Okay, so that's just a way of it's like a door basically. Okay, it's like a door that you can see, right? So and then you don't care about the details. Okay. So socket are file descriptors. Okay, so you will see FD. FD means file descriptors. Oh, we also of course handle. Okay, internally it's actually a complex structure, right? When you have a port, let's say I have a port number 123. Okay, actually it's preparing a lot of results for you. But when you access it, it's an array, right? So you just say, hey, I want to access this. This will point to, it's like a pointer. Okay, right? So you will point to the results. So actually, we just need an integer to describe that port. Okay, but actually it's associated with a lot of data. That's why you need to close the socket after use. Okay, and it's like a file descriptor because those things are like files. Okay, each port application has like communication. So actually, the reason is because these are called I/O device. Okay, I/O device. Maybe you think writing to a file is I/O, right? File. But if you look at your keyboard and console, they are also I/O devices. Okay, and the network is also I/O device. It's just a different kind of I/O devices. Okay, so to the operating system, there's no difference. You write to a file, you write to console, you write to a you write to the network interface card. It's the same idea. Okay? It's just a stream of strings or bits going out. Okay, and so this is why we call it file descriptor. Okay, and the socket calls are blocking, which means if you call that, it will block the thread. Okay? It will wait until things get back. Right? So if you say receive, until the other side do send something, and then you get it. Okay? If getting to the string, you receive. Okay, and that's why we do multi-threading. Right? If this gets stuck, it's put into operating system queue. Right? Because you have another thread, you can continue to use the available CPU core to run some other request. Okay, right. But here we will not choose we are totally blocking. We are single threading. Okay? Yeah, so they are not these sockets. Okay, this is really file descriptor. And here's an overview of our socket programming process. Okay, and so this is exactly the same as you see in the Python code, right? But it's in C API. Okay, find, listen, create socket, connect, and send stuff, get response, and close. Okay, right. And But I don't think we have time, so we will continue next time, okay? But just keep in mind these APIs are the same as Python. And I would strongly recommend you to read that chapter before the next class so that you can understand better, okay? All right, so that's the end. And oh, I think I forgot to take attendance. Let's take a, let me see, do we have time? Maybe we will take attendance next time, okay? Yeah, so that's all for today because time is past. Let me see a question. Could we get a program assignment instruction earlier, please? Okay, yeah, so we will release the instructions early next week. Okay, we will not release it for some considerations because you will have the lab assignment very soon, right? So we don't want overlap. Okay. Yeah, we will early next week we will release it. Okay, right. Because some students may be happy if we release two hands-on together, right? Because we will release a lab assignment very soon. Yeah. Okay, that's all for today. Any questions? If you have no question, feel free to disconnect. Okay, I will see you next Monday. And if you have a question, feel free to ask now. You will have 3 weeks because especially, I think it's not difficult actually. If you are familiar with programming, then it should be done very soon. But we will have 3 weeks just in case students have problems. Okay, and you do need to demo stuff to the TA. Okay, so these labs also set up for you to have enough time to demo your result to the TA. And start teaming up early. Okay, you can talk to your friends, and if you have difficulty, yes, the answer is 3 weeks. You have 3 weeks to finish. Okay, and if you have difficulty teaming up, you let the TA know. Okay, I think the TA will help you teaming up a little bit by making the TA office hours. No, group is voluntary, right? If you want to work with other students, then you group. Okay, I see whether it's random assigned. We are not a random assigned group. Okay, you can work alone also. Okay, 1 or 2 students, right? And so if you have difficulty, go to the TA office hours. Okay, TA will help you set up some breakout rooms so that you can chat and see whether you can team up. Because of the pandemic, unfortunately, so we cannot physically interact directly. So we need some way. Okay. Okay, thank you. So if you have, I see another question. Okay, yeah, it's not for me. I think yeah, these days, people are using microservice, right? Like Flask. Okay, so there's a new technology. Okay, but down there, actually, it's also capable. Okay, so yeah, I will see you guys next time. Have a nice weekend.